Dear students, in today's lecture we will study about three-phase transformers. Three-phase transformers are majorly used in power generation, transmission and distribution systems. So that's why it's very necessary for us to understand the design and operation of a three-phase transformer. There are two ways to construct a three-phase transformer. First one is simply take three single-phase transformers and connect them in three-phase bank. In second way, make a three-phase transformer consisting of three sets of windings wrapped around a common core. A single three-phase transformer is preferred because it is lighter, smaller, cheaper, and slightly more efficient. Other than this, there are also some other advantages and disadvantages of three-phase transformers over single-phase transformers, which are that these are have less time required to assembling, require less space, deliver more power, higher efficiency, easier to install, easy to repair. Also we can get single phase supply from three phase supply, while it is not possible to get three phase supply from single phase supply. If we know about the if we want to know about the disadvantages of three phase transformer over single phase transformer, then it can be that it has a greater cost of standby units, increased cost and inconvenience by repairs. But in single phase transformer, if single phase transformers are connected to each other to form a three phase transformer, and in that case if one transformer is out of order, all the other two would be working. But in three phase transformer, if one transformer is failed, then other two would not be working and whole the system of three phase transformer will be failed. So this is the first case where three phase transformers bank with independent transformers. So we have taken three independent single phase transformers and we have connected them to make a three phase transformer. Similarly, single phase transformers can be combined in any number to make them n number of single phase transformers can be connected to each other to make n phase transformer, like up to 24. It's quite easy to make them 24 phase transformer. This is the second case. We are using a single core and we are using a one core three phase transformer which do not have three different cores, but in this case we have our windings done on a single core. There are a different ways of connections in the three phase transformers. The main four possible connections can be: one is the Y to Y connection, the second one Y to delta connection, third one delta to Y connection, and then at the fourth one it is delta to delta connection. Any single transformer in the bank behaves exactly like a standalone single phase transformer. The impedance, voltage regulation, efficiency and similar calculations for three-phase transformers can be done on per phase basis using the techniques established for single-phase transformer. So first of all, we have a look on the first connection type, first connection possibility, which is the Y to Y connection. In Y to Y connection, we have input voltage, which is shown over here as VLP, output voltage VLS, and then we have two Y form circuits on left hand side and right hand side, on primary side and on secondary side as well. In this case, it can be seen that VLP is equal to under root 3 of V5P on the primary side. Similarly, if we see on the secondary side, VLS is also equal to under root 3 of V5 of S. But if we want to take the transformation ratio of a three-phase transformer having Y to Y connection, then it would be V5P over V5 of S. A is showing here is represented for the transformation ratio. It can also be seen if we divide VLP and VLS, then this under root 3 would be cancelled with each other, and we will get this V5 of pi over V5 of S, which is also equal to A. The same Y to Y connection as shown in the previous slide is simplified in this slide, and that's the same connection, but this is simplified to understand for a better understanding. So VLP and VLS are shown against C and B points, and on the secondary side B bar and C bar. So now we come to the second possible type of connections of three-phase transformers. The second possible type is Y to delta connection. In this case, the primary windings are in the Y circuit form and the secondary windings are in the delta form. In the delta form, the VLS can be seen equal to V5 of S, but on the primary side the VLP is equal to under root 3 of V5 of P as seen in the previous case. Now we again find the transformation ratio, which comes V5P over V5 on the secondary side, or if we divide VLP over VLS, then it would be equal to under root 3 of V5 of P over V5 of S. But we know V5 of P and V5 of S is equal to A, so we substitute this value with A. Now this second scenario has been simplified for the better understanding of the students. In this slide, this is the same circuit, just it is simplified to understand how the primary and secondary windings have coupling among each other. Now we come to the third possibility of connections, where the first case have delta connections and the secondary side has the Y form of circuit. In this connection, the VLP on the primary side would be equal to V of phi P, but on the secondary side it would be under root 3 of V of phi S. If we want to find the transformation ratio as we have found in the previous two cases, in this case it would also be equal to V phi of P over V phi of S, but as we find the voltage on the primary side over ratio of voltage over the secondary side, it would be V phi of P over under root 3 V phi of S. But we substitute the value of V phi of S over V phi of P is equal to 1 over A over here, which will be in the denominator, which will come on the numerator. The A will emerge on the numerator. So the new equation would be A over under root 3. Similarly, the same circuit diagram is simplified in this slide to see how the couplings among the primary and secondary windings are done in the delta to Y connections. Now we come to the last possible connections scenario, which is delta to delta connections. In this case, the primary winding have also a delta circuit, and on the secondary side there is also a delta connection circuit. So voltage on the primary side would be equal to V phi of P. Similarly, on the secondary side it would also be voltage V phi of S. To find the transformation ratio, V phi of P over V phi of S is equal to A, which is the transformation ratio, and it would also be equal to V on the primary side on V on the secondary side. This circuit is also simplified in this slide, and this shows how the circuit is coupling among each other. The primary side and secondary side of three-phase transformer is coupled with each other. Now we summarize these relationships for all the four connections of the three-phase transformers in this slide. So this relationship is basically as discussed in the previous slide. This is for Y to Y connections. Then the next relationship is for Y to delta, and then we have delta to Y, connections, and then there is delta to delta connections. So we can see that in Y to Y connection, VLP over VLS is equal to A, and we can easily find transformation ratio from here. In the second case, VLP over VLS is equal to under root 3 into A. We can also find transformation ratio by taking under root 3 on the left hand side, and on in the third case, in delta to y, VLP over VLS is equal to A over under root 3, and similarly in all these four uh, transformation ratios formulas can be used in solving the examples or numericals of related which are related to three-phase transformers. Thank you.